Hello, everybody, and welcome to Thursday, February 11th, 2021. Mr. Parrott here with your science rundown of what we're doing today. And it's a big day here, so make sure that you pay attention all the way throughout. Don't skip past anything because this is going to be one of the fundamental tools that we are going to use throughout the course of this unit. And today is your introduction to it. That thing is called the Punnett square. So first and foremost, make sure that you do your bell ringer. You should already have your Mendel assignment turned in because when you did it, it automatically turned in when you submitted it. So hopefully that you got that finished. But for today with our Punnett squares, we're going to go ahead and take a look at our notes. It's number 4 in our notes. To solve problems involving the Punnett square. First thing, we got to know what the Punnett square actually is. And I'm going to move myself here momentarily so you can see it. Punnett squares are the tool that we use to help figure out genetics, and specifically the probability of things. It was invented by this guy right over here, Mr. Reginald Punnett, to basically go off of what we talked about with Mendel and show the chances of you inheriting certain things or you passing on certain things from parent to the offspring. It'll involve both knowing the mom and dad alleles and then how those alleles will come together to form the kids' alleles, which will make up their genes. So we're going to talk about all about that today and what that ends up doing for us. So these letters. You saw the letters yesterday pop up a little bit as far as Mendel did, and if you watched that video, they talked about the numbers, or the letters. The letters represent our alleles. And there's always 2 letters because we get 2 alleles from your parents. 1 from mom, 1 from dad, 2 makes you. 1 plus 1 is 2, 1 plus 1 makes you, as far as our alleles go. So you have 2 things for each trait. We use the letters to show what type of alleles you actually have. I'm actually going to go down in this corner here so you can see all this stuff. We use the letters to show what type of alleles that you actually do end up having, to where we use capital letters to represent if you are dominant, and we use lowercase letters to represent recessive alleles. So there is 3 outcomes that you could be based off of your alleles. You could have 2 capital letters, meaning that you're dominant. You could have 2 lowercase letters, meaning that you're recessive. Or you could have 1 of each, where you are dominant and recessive. The key is, with all of this, and that's what's illustrated in this box over here to my side, that's circled, is that when you have 1 of each, in this case, big B, little b, if you have a big B and a little b, you are going to still show the dominant trait, which in this case is having the dominant brown eye instead of having blue eyes to it. So dominant always overpowers recessive. We've been talking about that the last couple of days. It's going to be a theme that's going to be happening. So that's what's up with the letters. We're using capital and lowercase letters. We always use the same type of letter when using the same trait. And we never switch letters. So that's why in this case we're using capital lowercase b's. You'll see capital lowercase a's, capital lowercase t's. There's going to be different letters that we end up using, but we use the same letter to represent one trait. So we never combine letters in this case. So you'll never have like an A and a B in this case. It'll just be either all A's or all B's. We use the capital and lowercase to make the distinction between them. So, how you do a Punnett square. I'm going to just list out the steps, and I'm going to do that with you in a little picture here. So let me do a little picture in a picture here. Let me just get a big old white space here. You may not be seeing my behind the scenes part here, but here's my drawing area that I'm going to do. And I'm going to do it step by step. First thing you're going to do, you're going to draw a box and divide it into 4 squares. So draw a box. Boop. There's our box. We're going to divide it into 4 squares. I'm actually going to push this over more towards the side here. Let's see if I can get it shrinky-dinked. There we go. There, you can see my square as we're doing it. Going on with it. You are going to write the male and female alleles along the outside of the box. This is mom and dad. And for purposes of just all of us being the same, we're going to put dad up top and mom on the side. So this one up here is going to be dad, and this one over here is going to be mom. And let's just use the letter B today. Let's do the brown eyes, blue eyes. Let's say dad is having brown eyes, and he's purebred, which means he has two of the same. Let's say mom has blue eyes, which means she has two recessives there. You put the alleles on the side, and they're alleles because there's only one of them. You do not put two on the side. These would be the two that they would have. Each one gets separated. What you end up doing is that you copy all of one parent's into the boxes below. So this is called the drop method. So because dad has a big B, we're going to put a big B in this box. And we're going to put a big B in this box because we are essentially just dragging down whatever dad has. On this column, we're going to do the same thing. Since he has a big B, we're going to put big B there. And we're going to put a big B there because we are dragging his alleles. On the left side, he's donating these ones. On the right side, he's donating these ones. Because he has a chance of donating either the left big B or the right big B. You're then going to do the same thing with the mom's traits. And with the mom's traits, you're going to use what I call the drag method because you're going to drag it from the left to the right into the boxes. So we get a little b to enter the boxes because we drag it in there. And then we have our completed Punnett square showing all the possible combinations for the baby in this case. That is what the inside portion is going to be. These are the different possibilities for the baby. So in this case, 100% of the outcomes are going to be a big B, little b for the child. They cannot have any other configuration based off of what mom and dad's traits are. Now, there's different ways that we can analyze it. This video is going to once again go over what we just did together. So take a look at it. She'll break it down again. If my way doesn't make any sense to you of how we just did it there, they'll also break it down. It's just good to have it repeated in a slightly different way so that you might have a better chance of understanding it if you hear it again, but presented just a little bit differently. So they'll explain a little bit about what's going on with that. And then we're going to do a couple of these practice ones together here because you're not able to actually join us to do these, so we're going to do these together. So if you want to pause the video and try to figure out this Punnett square before I solve it, now would be a time to pause the video and then hit record after you try to solve this. So I want you to solve this, so pause it right now and then hit play when you come back here. Otherwise, I'm just going to go through solving it. So here we got two different combinations here. We got dad up top is a big B, big B. He would have brown hair because that's the dominant trait. Mom on the side is big B, little b. She would have one of each, but she would also have brown hair because remember, brown hair always dominates. So she has at least one big B, so she's going to be dominant for that. How you do this is that you drop dad's genes down, and then you drag whatever mom has. Mom has a big B up top. So we'll put some big B's in, and then she has a little b down below. And we have a little b here. Now, what we haven't really done yet is break this down. How we can break this down is by looking at the percentages. We can look at how many are dominant, and we can look at how many are recessive. And what these are is that we're going to get a little probability here going on with it, because each one of these boxes represent 25%. Because total, it equals 100, so each one of these is 25. I'm just going to put 25 in each one of the boxes here. How you figure out the combinations of these things is that you look at it and be like, how many boxes are going to be dominant? So you go and count them up. Dominant means that they have just one capital letter in them because they have the dominant characteristic. So this one has a big B, so we got 1. This one has a big B, so we got 2. This one down here has a big B. That counts as dominant. That would be 3. This one down here also has a big B. That would be the 4th one. Because each one of these is worth 25, we would go 25 plus 25 plus 25 plus 25, which would get us 100% of it being dominant, 0% of it being recessive, because none of the boxes have little b in them. Let's look at another example. So this is just the percent chance having the blonde hair versus, and you can use this the same way. So since dominant means brown hair, recessive means blonde hair, when you go to this question here, it says what percent chance will the offspring have blonde hair? Blonde hair is recessive, so it would be 0% chance. So it would be over here for 0%. Let's look at the next one here. Let me get up my tool here. Oh, don't tell me that. Nope, okay. Good. Copy it over. Put this back on the screen. So here's our outcome. So once again, I want you to try this before you listen to me explain it. So go ahead and pause the video, work this Punnett square out. I'm going to show you how to do it though. First off, start with Dad up top. He's got a big T in this column, so we'll put big T's in. And he's got a little t in this column, so we'll go ahead and put some little t's in. Then go to Mom. Mom has a little t up top. Go down to the bottom. Mom has a little t across the bottom. And now we can figure out how many are dominant, how many are recessive with this one here. Remember, dominant is always going to have at least one capital letter in it. So here's a capital letter, and here's a capital letter. So 2 out of the 4 boxes are dominant, which would be 50%. For recessive has to have both lower cases in order to be recessive. 2 lower cases, 2 lower cases. Recessive would be 50%. Take a look at our question. It says what percent chance of the Punnett square will be short? If we take a look at what we just did here, short is a little t, so we're looking at little t combinations in order to getting the short trait. We said recessive is 50%, so the short characteristic would be 50%. That's our basis of our Punnett squares. Now let's take a look at what you're going to be doing for your homework, which is these Punnett squares. So we got the assignment Punnett squares. Go ahead and load that up. I'm going to load it up here. It's in your folder. This one I'm giving you 3 attempts again on because it's a little bit more in-depth. So you got your standard questions involving what is dominant, what is recessive, all this stuff, and then we have the Punnett squares itself. Some of them we're going to have all the way completed, and you're just going to analyze the results of the Punnett square. So in this case, it says, what's the percent chance the offspring will have yellow pods? Yellow is a recessive characteristic, so we're looking at little g, little g, little g, little g for them. In this one, you are going to be dragging and dropping the different options to fill out, just like you would drag and drop things into there. So you got 3 different options because you're either big H, big H, little h, or little h, little h. You'll have to figure out what ones will be put into each column there. Not all of them will be used, by the way. Those are just the 3 outcomes there. You might not use one of them. Just like in our other Punnett squares, we didn't use all the different combinations that existed. So do the drag and drop method. So in this first one here, I'll give you an example. There's a big H coming down from Dad, a little h coming down from Mom, so that'd be a big H, little h right there in the corner. You're going to then be asked some questions based off of that Punnett square, so you might have to go back and forth between the two. Like in this one, it says in question number 6, what is the chance the offspring will not have horns? So we give you the fact that H means horns, little h means no horns. So we're looking for the ability to inherit horns, which would be meaning one capital H in there for them. So take a look at some of those problems there. You've got a couple of them as we go through. Just using some different methods. So there's 3 Punnett square problems there at the end for you to answer and then to analyze at the end of it. So that is your assignment. You got 3 attempts on it, so use those wisely as you're going through, because we want you to really understand the Punnett square thing. So make sure that you take it multiple times, especially, or if you need to really make sure we solidify these ideas. If you have questions about how any of this stuff works, do not hesitate to email up, because this is one of probably the more, not necessarily difficult, but one of the key things that we are going to make sure to get locked down is the Punnett square business. So make sure that you're checking in, answering questions. If you have any questions, email. The video went a little bit long because there is a lot more to explain today. So hopefully you stayed tuned until now. Hope to have you back in class, because it is a lot easier to show you how this stuff works in class than it is through the video means there. But hopefully you're able to pick up what we're putting down here. Hopefully you're back with us tomorrow. I know a bunch of you are coming back tomorrow that are currently quarantining, so hopefully we'll see a whole bunch of you here on Friday and we can work through what we didn't do, all that kind of stuff with it. So make sure that you are checking and trying to stay as current as possible with things. But until then, email if you have any questions, and I will see you later. Bye.